So what we have here is a question which requires dimensional reasoning in order to figure out the solution. So the question here is, if the net calorific value of dry wood is 2 megajoules per kilomole, how much energy is released when 1 kilogram of wet wood at 30% moisture content is burnt, assuming that the dry wood has a molecular composition of CH 1.40 0.6. Now, with dimensional reasoning questions, it's very important to think about what the question's asking and carefully consider all the terms that you're given. So here, what we're really looking for is a value which we'll call E, which is the amount of energy that's released. And we'll give that the unit of megajoule because I suppose it's easiest because the NCV value we're given is also in terms of megajoules. That's going to make the calculation a little bit simpler. So what we're really looking to do here is to construct some sort of formula from the given information, but this isn't a formula that you would recall from memory. It's one that you kind of construct using the information and some common sense. So the energy is going to be related to the net calorific value. So the underscore notation here indicates that this is megajoule per kilomole, and I'm going to use the subscript D here because we're told that this is in a dry wood basis. In order to get dimensional consistency, we're then going to have to multiply this by N, the number of moles or kilomoles of dry wood. Okay, so notice on both sides you have dimensional consistency. On the right hand side, kilomole dry crosses out with kilomole dry, and everything works out fine. Now the only problem here is that we don't actually know what N is. We're given that we know the mass of the wet wood, but we don't know how many moles of dry wood is used. So what we do then is look for an answer to this term that we don't know. So if now we consider N dry to be the term we're looking for. So when converting from mass to moles, you'll commonly use molecular weight. So the relationship here is if we know what the dry mass is, which has units kilogram dry, if we divide that by the molecular weight, represented by the symbol capital W here, which has units kilogram of dry wood per kilomole of dry wood. So you can see this will convert easily between it, and if you want to get a mass from a mole, you just change the subject of the equation. So you see that these terms drop out, and again we have consistency. So now you have to figure out what the mass of dry wood is and what the molecular weight is. The molecular weight is very straightforward. So you can figure this out for any individual chemical species or any mixture of chemical species. In this case, we only have one thing, and that is the dry wood itself. So if we remember what the formula is for dry wood, it was CH 1.40 0.6. So this is telling us the ratio in which each of these elements occurs on average in 1 kilogram of wood, or kilomole of wood I should say. So what you need to do to figure out the molecular weight of this composite material is to sum over the individual elements, where Ni represents the number of moles of each element and Wi their molecular weights. So here you just need to remember that the molecular weight of carbon is 12 because there are 6 neutrons and 6 protons. The weight of hydrogen is 1 because there is only 1 proton, and the weight of oxygen is 16 because there are 8 neutrons and 8 protons. So if we take our molecular weights and our composition, we get 1 mole of C by 12 plus 1 of hydrogen by 1.4 plus 0.6 kilomoles of oxygen by 16. And it turns out that this gives us 23. That's kilogram dry wood, kilomole dry wood. So this term WD that we were looking for, we now know. We just have to consider mass of the dry wood. In this course, you'll frequently have to consider cases where you have some amount of wood with some amount of moisture, and you may need to figure out how much dry wood there is or how much liquid water there is in the mixture. So the way to think about this term, which we call moisture content, which I'm going to give the symbol lowercase w, and has units kilograms H2O per kilogram of wet wood. So think about this in terms of having 1 unit mass of wet wood. So let's think of this as 1 kilogram of wet wood. Now, if we conceptually separate the dry wood component and the water component, then what we see is that this term W is equal to the amount of H2O over the amount of total, so dry wood plus H2O. We're writing this with units and symbols. This is mass of H2O in kilogram H2O over mass of dry wood, kilogram dry plus mass H2O with units kilogram H2O. Alternatively, you can write the mass of dry wood and mass of the water is equal to the mass of the whole wet mixture. So we get mH2O kilogram H2O over the wet mass. Now, this all seems long-winded, and it kind of is, but it's an important point to understand, because what we actually need here is not the mass of water per mass of wet wood. We need the mass of dry wood per mass of wet wood. So if we know that m of the wet mass is m of the dry mass plus m of the water, and we then divide through everything by mw, mass of the wet wood, you can see that we get this relationship of the dry mass per wet mass, and this here is the term moisture fraction which we defined earlier. So we now know that the mass of the dry over the mass of the wet is 1 minus W, or it's a complement to the moisture fraction. So now we are almost having the expression that we're looking for, because we were originally after the mass of the dry wood. So we can say mass of the dry wood, kilogram dry, units is 1 minus W, which we discovered has units of kilogram dry, kilogram wet, by MW, which of course has units kilogram wet. So we cancel the units again, we see everything's consistent, so we have derived the correct expression. Okay, so that was a really roundabout way, but we've now figured out all the terms that we need to know. So previously, when we were looking for the number of moles of the dry wood, we now have an expression. So N dry, which we said was M dry over W dry, can now be written as 1 minus W, sorry, let's move that up, 1 minus W M the wet wood over W dry, and the expression for energy now, which we said was NCV by N dry, can be written as NCV 1 minus W mass of the wet wood over the molecular weight. And we have the numerical value for all these expressions. So NCV was given as 2 megajoules kilomole dry. 1 minus W we can figure out is 0.7 kilogram dry per kilogram wet. And the mass of the wet wood was just 1, and W we figured out, sorry, let me just move all this up. W we figured out was 23 kilogram per kilomole on a dry basis. So I'll just write that out one more time just to make it clear how the units are all consistent. So energy in terms of megajoules equal to NCV on a mole basis, megajoules kilomole dry by 1 minus W, which has units kilogram dry per kilogram wet, by mass of the wet wood, which has kilogram wet, all over molecular weight, which has units kilogram dry, kilogram wet. So let's just go through, make sure there's consistency. So on the top we have kilogram dry, on the bottom kilogram dry, kilomole dry, sorry, made a mistake here, that should be written kilomole dry. On the bottom, on the top, on the bottom, on the bottom, so that cancels out. And then kilogram wet cancels out, so we have consistency. So you can sub in the numerical value and figure out the answer.